NASA just confirmed what SpaceX feared most. Dream Chaser landed on a runway like any commercial jet, while Dragon capsules still splash into the ocean like expensive rocks. Sierra Space secured $1.5 billion in contracts. SpaceX still explaining rocket explosions to investors. But here's the real shocker. Why is NASA quietly shifting away from Dragon missions? What does Sierra Space know that Elon doesn't? Let's dive right in. The SpaceX empire's hidden weakness. NASA's quiet shift away from Dragon missions tells a story SpaceX doesn't want you to hear. For 23 years, everyone watched Elon build an empire. Government contracts worth billions. Starlink satellites printing money. Defense deals that seemed untouchable. But empires built on single points of failure don't last forever. Every Dragon mission ends the same way. Splashdown, ocean recovery, waiting, hoping the parachutes deploy correctly. It's like throwing $1 million car into a lake after every drive, then spending weeks fishing it out. Sierra Space saw this weakness and built the perfect weapon to exploit it. The $1.5 billion Shockwave, June 11th, 2024. While SpaceX was making headlines with rocket catches, Sierra Space dropped a bombshell that shook the Pentagon. Victory Works facility, 60,000 square feet of pure ambition, backed by contracts worth $1.5 billion. That wasn't just money. That was America betting its national security on a 4-year-old company. The $740 million slice alone, 18 military satellites packed with fire control sensors, the backbone of America's missile defense system. While Dragon capsules were splashing into oceans, Sierra Space was becoming indispensable to national survival. But here's what nobody saw coming. The 2024 Space Force report revealed America's nightmare scenario. Enemy nations developing rapid strike capabilities, anti-satellite weapons, space warfare moving from fiction to reality. The military needed spacecraft that could respond in hours, not weeks. Dragon capsules? Still bobbing in the Pacific, waiting for recovery ships. The landing that changed everything. Picture this moment. Dream Chaser approaches the runway at 200 miles per hour. Landing gear extends smoothly. Touchdown, rollout, stop. Astronauts walk off like they just landed from Chicago. No splash, no recovery fleet, no prayers that parachutes work. Meanwhile, Dragon crews float in the ocean like expensive fishing bobbers, waiting for million-dollar rescue operations, hoping rough seas don't turn their homecoming into a nightmare. The operational difference isn't just dramatic, it's revolutionary. Dream Chaser can land at over 500 airports worldwide. New York, Tokyo, London, Sydney. Bad weather at one airport, divert to another. No ocean recovery zones. No weather delays. No multi-million-dollar rescue operations eating into profit margins. But the real advantage runs deeper than convenience, the Swiss Army knife strategy. SpaceX built Dragon for one job: crew transport, cargo delivery, simple missions with simple goals. It's like owning a really expensive taxi. Sierra Space built Dream Chaser as a transformer. Crew missions? Check. Cargo runs? Check. Satellite servicing? Check. In-orbit manufacturing? Check. Military reconnaissance? Check. One spacecraft, infinite possibilities. The rocket-agnostic design means ultimate flexibility. If Vulcan fails, launch on Atlas. If Atlas is unavailable, switch to Falcon Heavy, Dragon. Married to Falcon 9 forever. That's not strategy, that's vulnerability. And here's the detail that should terrify SpaceX. Consistency in SIA, as in con. Dream Chaser uses non-toxic propellants. You could literally refuel it at a civilian airport. Dragon relies on hypergolic fuels so dangerous that one drop on your skin means death. Which spacecraft would you rather have your family near? The 210-day game-changer Dragon missions last weeks. Dream Chaser missions last 210 days. That's not just longer, it's a completely different universe of possibilities. Pharmaceutical giant Merck discovered this advantage first. 3D printing protein crystals in microgravity for months instead of days, potentially revolutionizing cancer treatment. The longer missions mean breakthrough discoveries that short flights can't achieve. But the military implications are staggering. 210 days of continuous surveillance, monitoring enemy satellites, tracking ground movements, collecting intelligence that could prevent wars before they start. Dream Chaser isn't just a spacecraft, it's a strategic asset disguised as a delivery truck. And unlike Dragon, which needs constant communication with ground control, Dream Chaser can operate autonomously for the entire mission. Communication blackout? No problem. Ground control compromised? Still operational. The abort capability that saves lives. NASA's space shuttle had a deadly flaw. Landing gear failure meant certain death. The orbiter couldn't survive belly landings. If cargo shifted during impact, it would crush the crew compartment. Game over. Sierra Space learned from those tragedies. Dream Chaser can abort autonomously. No ground control needed, no communication required. The spacecraft analyzes the situation, calculates the nearest safe runway, executes the landing, all without human intervention. This isn't just engineering, it's psychology. Astronauts launch knowing they can come home safely no matter what goes wrong. That confidence changes everything about space missions. Compare that to Dragon's abort scenario. Deploy parachutes, hope they work, splash into ocean, pray recovery ships reach you before hypothermia sets in. Which would you choose for your crew? The defense revolution nobody saw coming. While SpaceX celebrated Starlink's commercial success, Sierra Space was quietly building something more valuable, a defense empire. Their Eclipse satellite bus isn't just hardware. It's the foundation of America's early warning system. Every satellite they launch makes the country safer from missile threats. The timing couldn't be more critical. China developing hypersonic weapons, Russia testing anti-satellite capabilities, North Korea advancing rocket technology. America needs spacecraft that can deploy rapidly, survive attacks, and complete missions when everything goes wrong. Dream Chaser answers that call perfectly. Nation it launches like a satellite, operating with Saltation Mediclus, operates like a space station. In Autumn's office in Socktober Crush, lands like a fighter jet. The ultimate military tool, disguised as civilian technology. But here's the twist that changes everything. The payload paradox that reveals truth. Critics attack Dream Chaser's smaller payload capacity. It can't carry as much as Starship or New Glenn, they shout. But they're missing the revolutionary point entirely. Sometimes precision beats power. Ultra-sensitive military equipment survives gentle runway landings better than oceanic crashes. Emergency medical supplies reach any major airport in hours, not days. Classified experiments avoid saltwater contamination that could destroy months of research. It's like comparing a surgeon's scalpel to a construction hammer. Both have their place, but when precision matters most, smaller often wins. The real question isn't payload capacity, it's mission success rate. And Dream Chaser's runway landing capability gives it success rates that ocean-splashing capsules simply cannot match. The delays that revealed the master plan. Tenacity was supposed to launch in 2021. Then, 2022. Then, 2023. Now, late 2025. Critics called it failure, investors called it incompetence. They were all wrong. The official story blamed launch logistics. ULA's Vulcan needed Space Force certification. Dream Chaser got bumped for dummy payloads. Atlas V production ended. Only 14 flights remain for existing contracts. But here's what really happened. Sierra Space was perfecting something that could revolutionize space travel forever. Those delays weren't setbacks. They were investments in absolute perfection. Because when Dream Chaser finally flies, it needs to be flawless. The stakes are too high for anything less than perfect. Meanwhile, SpaceX's rapid prototyping approach led to spectacular explosion. Great for YouTube views. Terrible for investor confidence in crewed missions. Would you trust your life to a company that celebrates rapid, unscheduled disassembly? The storm that's already here. SpaceX executives aren't sleeping well these days. Sierra Space isn't just building spacecraft. They're executing SpaceX's own playbook, but better. Multiple revenue streams? Check. Government contracts? Check. Commercial partnerships? Check. Defense deals worth billions? Check. But Sierra Space has the one thing SpaceX doesn't, the ability to land anywhere, anytime, in any weather conditions. That's not just an advantage, that's checkmate. The space industry is about to witness something unprecedented. The empire that seemed unbeatable, facing technology that makes its flagship spacecraft look obsolete. Dragon capsules splashing into oceans, while dream chasers glide onto runways worldwide, recovery ships racing against time and weather, while astronauts walk off Dream Chaser like they just finished a routine flight. Multi-million-dollar ocean operations, while Dream Chaser refuels at civilian airports. The revolution isn't coming, it's already here, and SpaceX is scrambling to catch up to a 4-year-old company that just rewrote the rules of space travel forever. The question isn't whether Dream Chaser will succeed, it's whether the space industry is ready for what comes next. So here we are, SpaceX's Dragon, still splashing into oceans like expensive rocks. Sierra Space's Dream Chaser, gliding onto runways worldwide like the future just landed. The $1.5 billion question isn't whether Dream Chaser will succeed. It's what happens when every major space agency realizes runway landings beat ocean recovery every single time. But this story is far from over. Boeing's Starliner is struggling. Blue Origin's New Shepard faces delays. Virgin Galactic is pivoting strategies. The entire space industry is reshuffling, and we're tracking every move. What's your take? Will SpaceX adapt fast enough? Can Dream Chaser really revolutionize crew missions? Or is there another player we haven't talked about yet? Drop your thoughts below, because the space race just got infinitely more interesting. And if you want the inside scoop on what's coming next, you know where to find us. The revolution is just beginning. Flight 9 just happened, and Ship 36 is already rolling to the test pad. This isn't normal. SpaceX is moving at a pace that's breaking every rule in rocket science. Ship 35 tested just 5 days before launch. If Ship 36 follows that pattern, we're looking at Flight 10 in days, not months. But here's the problem. The 6-engine static fire has crushed SpaceX before, causing weeks of delays. One failure, and this record attempt dies. With 30 Raptor tests at McGregor this week alone, they're pushing harder than ever. Can they pull off the impossible? Let's dive right in. The speed that shocks everyone. Ship 36 wasn't supposed to be ready until August, maybe September. Yet here it is, rolling to the test pad just days after Flight 9. This breaks every timeline SpaceX has ever followed. Something massive is driving this insane pace. And it's not what you think. While we watched Flight 9's spectacular success, SpaceX was already moving mountains behind the scenes. Barrel sections streaming out of the Star Factory, not for assembly but for scrapping. Perfectly good stainless steel rings heading straight to the junkyard. Why destroy materials worth millions? Because they're not good enough anymore. The truth hits like a freight train. SpaceX isn't just launching rockets, they're racing against their own revolution. Block 3 Starship is coming, and it changes everything. But they need Flight 10's data to make it happen. Without that data, the entire Mars timeline collapses. The speed that shocks everyone. Ship 36 wasn't supposed to be ready until August, maybe September. Yet here it is, rolling to the test pad just days after Flight 9. This breaks every timeline SpaceX has ever followed. Something massive is driving this insane pace. And it's not what you think. While we watched Flight 9's spectacular success, SpaceX was already moving mountains behind the scenes. Barrel sections streaming out of the Star Factory, not for assembly but for scrapping. Perfectly good stainless steel rings heading straight to the junkyard. Why destroy materials worth millions? Because they're not good enough anymore. The truth hits like a freight train. SpaceX isn't just launching rockets, they're racing against their own revolution. Block 3 Starship is coming, and it changes everything. But they need Flight 10's data to make it happen. Without that data, the entire Mars timeline collapses. The foundation built on quicksand. Boca Chica soil fights back against every shovel, every foundation pile, every attempt to build something permanent. It's sandy, waterlogged, and utterly unstable. Yet SpaceX is attempting to construct the world's largest rocket factory on this swampy ground. The Gigabay project now runs 24/7, with floodlights turning night into day. Workers are literally racing against the ocean. Every tide brings more water. Every storm threatens to wash away months of work. The pile drivers hammer continuously, trying to reach bedrock that may not even exist. Foundation crews pump water out faster than it seeps back in. It's like building on the ocean floor while the tide comes in. This isn't just construction anymore. It's a desperate fight against nature itself.